what up, what up? We are now on chapter 2, and we're going to introduce one of probably two of the most important things that you will learn in this calculus 1, and that is the concept of the derivative. Oh, the derivative gives us so many things, but as my calculus professor from when I was an undergrad a few years ago told me, is if you remember anything, the derivative means slope. The derivative means slope. The derivative means slope. So let's talk about tangent lines and rate of change. As some of you might know, rate of change, well, I remember from in Algebra 1, rate of change is just a fancy word for, you know what? I'm not even going to give it away. Tangent lines give us a snapshot of a curve's behavior at a given point. We learn in chapter 1, probably the very beginning of chapter 1, that if I were to give you a coordinate plane, right, and if I were to give you a curve on that coordinate plane, and I were to say, that dot right there, if I were to put a dot right there on that curve, the slope at that point might look something like this. And of course that changes. The best way to view that is like if this green line represents a roller coaster, how level or where will like that roller coaster car be in reference to the ground? So if I was going down a hill, up a hill, in this area, my roller coaster car, I guess you call it a car, right? Bus? Nah. Would be facing downward. It would be like a negative slope, but then I go up and it would face upward and then I go down again. So again, at that moment, at that very point right there, that tangent line would probably look like that because the roller coaster car would be at that angle. The slope of a slope of a tangent line is at a point we call P x f of x. Remember, f of x is the same thing as y, so yeah, we can call it xy, but it wouldn't be calculus if we call it xy. We have to overcomplicate things. This is the crazy part. That right there is the definition of the slope of the tangent line. Okay, the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x over h. So we are going to be tasked to, I believe in the next 6 problems, find the slope of the tangent line using that guy right there. So we'll be given an f of x value. We already have f of x. We're going to find f of x plus h, and then we're going to put all of that in the numerator, subtract the one from the other, divide it by h, do a little bit of math, hope that magic happens, and we will get the slope of the tangent line. Remember, slope is given to us by the letter m, so that represents the slope of the tangent line. Your book uses the same exact formula, but they use x sub-zero, but I'm not a fan of Mortal Kombat, so I'm not going to use sub-zero. You get it? All right. The first thing that we are tasked to do is to use that formula up there, the one we just learned, to find the slope of the tangent line for each. So this is what I'm going to do. This is how I'm going to set it up. Okay, y is f of x. So I already have f of x, and I'm just going to write it out because, why not? F of x equals 3x squared plus 1. F of x plus h means this. I take that original function and replace the x with x plus h. So I get 3 times x plus h squared plus 1. You might remember that x plus h is not as simple as x squared plus h squared, okay? This is a FOIL problem, so I have to set it up like this. X plus h times x plus h, you see what I did? Plus 1. Let me move it down here. I know this is not going to look like the prettiest thing in the world, but I already have that guy right there, and I'm just going to keep that guy going right underneath it, okay? This is a FOIL problem. X times x is 3. X times x is x squared. X times h plus x times h is going to be 2xh foil, plus h squared plus 1. Okay, if you're wondering where I got the 2xh from, I'm waving my hands a little bit. I got x times x, x squared, x times h, xh, plus x times h, which is xh again. So whenever we do a perfect square trinomial type thing, we're always going to get 2 of what we have for the outer and the inner. Okay, outer and inner. The oi in foil. Oi, oi. I don't know why I find that funny. 3x squared plus distributive property, 6xh plus 3h squared plus 1. So that's what f of x plus h ended up being. F of x plus h ended up being that. So now on to actually doing the problem. Okay. The limit as h approaches 0 of f of x plus h. I'm just going to rewrite the entire formula because I think I have the space, and I'd rather have you see the whole process than for me to try to cut corners. The limit as h approaches 0 of f of x plus h minus f of x over h is going to look like this. The limit as h approaches 0 of f of x plus h, which ended up being for us 3x squared plus 6xh plus 3h squared plus 1 minus 3x squared plus 1. Now, what am I missing? H. All right. Very confusing when I have all these colors that I have to deal with. So confusing. The next step is just to keep going with the math. H approaches 0. So I don't need these parentheses right here. I have 3x squared plus 6xh plus 3h squared plus 1. And then you distribute the negative here. Minus 3x squared minus 1 over h. At this stage, you might notice, wait a gosh darned minute. You cancel out, and you cancel out. Expect that to happen, or something like that to happen. Expect a lot of cancellations. Okay, so what we're left with is the limit as h approaches 0 of 6xh plus 3h squared. Well, wait a minute. I can factor out an h of that. So I'm left with 6x after I factor an h out plus 3h. Now, why do I care about factoring out an h? Well, look what's on the bottom, h. At this moment, am I allowed to plug in 0? Nope. And nope. And nope. And if you're looking at what's left over, remember, these guys are gone. They're gone. So all of this is a memory. And so all I have left is something h plus something h over h. And if I plug in 0 for h, I have a 0 up here and a 0 down there. And as we know, that's bad news. Okay. If I factor out an h, I'm allowed to just cut that out. In the words of Joey Gladstone, cut it out. Full house. As the limit of h approaches 0 of 6x plus 3h means I'm just going to plug in 0 to h. I have no h attached to here, so that stays. That becomes 0, and I just end up with 6x. So all of that work, and I turned 3x squared plus 1 into 6x. Let's do it again. There's my equation. F of x plus h means I take the... Oh, you know what I forgot to do? Let's backtrack. Let's reverse. I got 6x, but what I forgot to do is I forgot to plug in the point 213. So the point 213 means that's my x value. That's my y value. So actually, my real answer is 6 times 2, which is 12. And I'll put that in a little box. I don't really care about the y value because there's no y here. So my complete answer, my final answer is 12. Let me zoom out a bit. Let me adjust a little bit. Ow. Okay? Okay. Sorry about that. All right, now let's fast forward. So anyway, problem B. Y equals 4 over x. Whenever I'm asked to find f of x plus h, what I do is I replace the x up here with an x plus h. So f of x plus h is going to be 4 over x plus h. F of x is just 4 over x. So I'm like, and every time that I do this, I reuse the original equation that I'm given. Okay. Now that I know that, so the setup here is a whole lot easier than the setup there. However, finding the limit may not be easier. I guess there's only one way to find out, and that's to do the problem. The limit as h approaches 0 of f of x plus h minus f of x over h is going to be 4 over x plus h, and I'm going to skip some space for no reason at all, minus f of x, which is 4 over x, over h. Now, oh, you know what? And I forgot to say the limit as h approaches 0. How sloppy of me. The first thing I notice is, okay, well, I have two fractions up here. Can I combine them as is? Nope. But if I multiply the top and the bottom of this guy by x over x, and I multiply the top and the bottom by this guy by x plus h over x plus h, then I will have a common denominator of x plus h, and x plus h. So that's what I am going to do. 4 times x is 4x. Minus, be very careful, minus 4 times x is 4x. Minus 4 times h is minus 4h. My favorite type of club involving horses. Ah ha ha, yes. Yes, sir. That's going to be over x. I'll write this out as x squared plus xh. All of that is going to be over h. Or I will just write it as h over 1. Now, when you have a fraction divided by a fraction, what you should do is take the bottom fraction and multiply the top and the bottom by its reciprocal, like so. Remember, instead of dividing a fraction, multiply the reciprocal, and that's exactly what I did here. So what that will turn into is the limit as, oh, you know what? I don't need you anymore. The limit as h approaches 0 of negative 4h times 1, negative 4h times 1 is just negative 4h, over x squared times h is x squared h, plus x times h squared. See what I did there? Much better looking. Let's plug in 0. I get 0 over 0 plus 0. Oh, nuts. I can't do that. Silly me. How did I forget? So maybe I should bring out an h. Maybe I should factor an h out. So I factor an h out. Negative 4h basically just looks like that. If I bring an h out, I am left with x squared plus xh. That crosses out. So now I have the limit as h approaches 0 of negative 4 over x squared plus xh. Can I plug 0 in for h now? Mm-hmm. And when I do, u becomes 0. All right, sorry for the little interruption. For whatever reason, my screen turned black, and I just wanted to make sure you guys could see what I was doing to finish the problem out. All right, limit of h approaches 0. What I did is I can't plug 0 up in here because there's no h. I can't plug 0 in there because there's no h. And if I plug 0 in there, the h cancels out, becomes 0. So in the end, I get negative 4 over x squared. Am I done yet? Nope. I'm supposed to plug in 4 for x. So right here at the very bottom, I'm just going to squeeze that in. Negative 4 over 4 squared. Ooh, my favorite game involving 4 squares. It's going to be negative 4 over 16, which ends up being negative a quarter. So what this means is if I were to graph that equation right there, the slope of the tangent line when x equals 4 is going to be negative 1 over 4. Similarly, if I were to graph that guy, which is a parabola, the slope of the tangent line at the point 2, 3 is going to be 12. Regular 12. I know that looks like negative 12, but that's supposed to be part of an equal sign. Let's do more. Let's do more. Let's do more. F of x plus h is going to equal 2 times the square root of x plus h. And f of x is going to be 2 root x. So the limit as h approaches 0 of f of x plus h, I'm not going to rewrite out the equation this time because it's right there. I think we're good now. On your own, you really should, but I ain't. 2 root x plus h minus 2 root x over h. I guess the best thing that I should do here is I can't plug in 0 over 0. Or can I? I can. So I can't plug in 0 because of the h on the bottom. So I guess the best thing I can do, and the only thing really I can do, and I hate doing it, and I try to avoid it just now because I just hate doing it, is doing what's called rationalizing a function. Whenever you see square roots in the numerator and the denominator, usually your way to get around terrible things is by taking the exact same guy that you see here and multiplying the top and the bottom by that exact same guy and flipping the sign in the middle. So you have 2 root x plus h plus 2 root x, and then multiply the bottom by the same thing. FOIL up top. You get 2 times 2, which is 4, times x plus h, the root of that squared, which becomes x plus h. Okay, if that was too fast for you, 2 times 2 is 4. The square root of x plus h times the square root of x plus h is the same thing as saying the square root of x plus h squared, and the square root and the square root and the squared cancel each other out. What's going to happen here is I'm going to have this guy times that guy minus the same exact thing. So whenever you multiply a binomial times itself and flip the sign, the O and the I cancel each other out. And then this guy happens, and I get negative 2 times 2, which is 4. And then the square root of x times the square root of x is the square root of x squared. And so the square root of x squared is just x. That's going to be over 2 times h, so 2h, and then attach the x plus h, square root of it, plus 2 times h times the root x. All right, so one thing, well, let me show, I have plenty of space, so let me show all of my steps. Let's bring that over here and simplify and clean things up a little bit. The limit as h approaches 0, that foils out, or I'm sorry, distributes out to 4x plus 4h minus 4x, so magic happens right there. While I'm at it, I have 2h and 2h in common with both, so while I'm at it, I'm just going to factor that out. And I have the square root of x plus h minus the square root of x. Again, you're going to notice that the majority of these slope of tangent line problems, you're going to end up factoring out h. And we're going to see that here because this happens. Right? And so if all I have upstairs is 4h, my favorite type of club, and I have 2h times stuff, the h's cancel out. And actually, that 2 simplifies, and that 4 becomes a 2. See what I did? And so now what I'm left with is the limit as h approaches 0 of just 2 in the numerator times the square root of x plus h minus the square root of x. Well, my screen did that thing again where it went black, so I'm not sure what's going on with the old Chromebook here, but it's kind of a blessing in disguise, because what I didn't realize here is that that was supposed to be a plus sign. So after I looked at my computer and was like, hey, what the heck? I also realized, hey, what the heck? That's a plus sign, you big dumb goof. That's what I said to myself. You big dumb goof. And so I deserve saying that to myself. But anyway. What happens here is I'm allowed to plug in 0 for h. And so when I do that, that cancels out. And I'm left with 2 over root x plus root x, which is the same thing as 2 over 2 root x's. Cross that out, which is the same thing as 1 over root x. Am I done? Of course not. I'm given a point. I only care about the 1 or the x value here. So I'm going to plug that in, which ends up being 1 over the square root of 1, which ends up being 1. All right. Good. Let's see if we can get through this problem without any blackouts. Hey, what are we trying to do? Watch the Sixers on Xfinity or whatever, and forget it. I'm trying to make a blackout joke about sports because there's no other blackout that I can think of that you college kids could possibly understand. All right. Let's do it again. I have f of x plus h. My goodness. I have f of x plus h equals negative 3x plus h minus 5. Let's do a little simplifying. Negative 3 times x is negative 3x. Negative 3 times h is minus 3h. And then minus 5 comes along for the ride. Then I have 5x, which is negative 3x minus 5. My equation is there. I'm not going to rewrite it. My limit as h approaches 0 of f of x plus h is the same thing as me saying negative 3x in parentheses minus 3h minus 5. Now I'm going to subtract f of x, which I absolutely must remember that I can't forget the old parentheses. Otherwise, it's going to fall apart on me, and I don't want that. That's going to be over h. Drop through the parentheses in the first one. I don't need it. Negative 3x minus 3h minus 5 minus negative 3x is plus 3x. Ooh. Minus negative 5 is plus 5. Ooh. All over h. Again, because I had you cut off. Drop the parentheses in the first paragraph. Negative times a negative is positive 3x. Negative times a negative is positive 5 all over h. Negative 3 and 3x go away. Negative regular 5 and 5 go away. That leaves me with the limit as h approaches 0 of just negative 3h over just h. Boom. And so if I plug in 0 to absolutely nothing, I just get negative 3. Boom. Mr. Perich, you're saying. I'm sorry, Professor Perich, you're saying. You forgot to plug in x. No, I didn't. Why? Try to plug 2 into something that doesn't have an x. Boom, roasted you. Got you. The answer is negative 3. So no matter what, and that makes sense. If I were to ask you to find the slope of a tangent line of a linear equation, okay, this equation when graphed is going to look something like that. So no matter where I put a dot, the slope of the tangent line of a linear straight line is always going to be negative 3. The slope of that guy is negative 3 anyway. So no matter where I put a dot, I'm going to get negative 3 for a slope. You see, it all makes sense. Dollars and cents. Okay, at this stage, we're all experts, but we're just going to do these problems anyway because it's fun, and I love having fun. You can't spell function without fun, and these are talking about functions, baby. Speaking about functions, the first function that I'm going to write out is f of x plus h, which is going to be 2 times x plus h squared. Remember the very first problem that we did? We had a similar problem. X plus h squared is not x squared plus h squared. X plus h squared is x squared plus 2xh. No. Plus h squared. And that just turns into 2x squared plus 4xh plus 2h squared. All right. And then f of x is just 2x squared. The limit as h approaches 0 of f of x plus h is going to be 2x squared plus 4xh plus 2h squared minus 2x squared. That's going to be over h. It's going to turn into the limit as h approaches 0 of, don't need those parentheses, 2x squared plus 4xh plus 2h squared minus 2x squared. Oh, how about that? I didn't think that things would just disappear like that. And oh, how about that? How about that? There's an h in common with all of them. So I'm going to bring that out. 4x plus 2h over h. So when I plug in 0 for h, you go away, and I'm just left with 4x. I care about what happens at negative 1. So my slope at that point is negative 4. Now, for a couple of the problems, I've given some visual representations. If I wanted to graph that guy right there, if I wanted to graph it, it would look something like this. So at the point negative 1, 2, which might live right there, my slope of the tangent line is negative 4 at that moment. Now, I know my picture's not the best picture because it doesn't really exactly look like that's a negative 1, 2, and that doesn't really look like a slope of negative 4, but my heart was there. My pencil, not so much. Not so much. B harkens back to a similar problem that we did before, where I have f of x plus h is going to equal root x plus h, and f of x is just root x. So the limit as h approaches 0 of f of x plus h is going to look like root x plus h minus f of x is going to look like root x over h. Remember what we did in the problem before is right now, if I plug in h equals 0, the whole thing blows up and, I'm not allowed to do that. I can't have blowing up. Blowing up is no good. So what I'm going to do is I'm going to multiply the top and the bottom by the exact same thing that I see here, but I'm going to flip the sign in the middle. So I have root x plus h plus root x over h. I'm sorry, x plus h plus root x. Oh, children, if you want me to not cap right now, I'm not capping at you. I didn't sleep very well last night, so it's the life that you live when you have 4 children, 5 years and younger. You just don't sleep sometimes. X plus h, root x plus h times root x plus h ends up being x plus h. That's the FOIL part. Whenever you do this, the O and the I cancel each other out, so that's gone. And I'm going to have minus root x times root x, which is root x squared x. This becomes x times h plus x plus h. Actually, you know what I'm going to do? I'm going to leave it like that because I have a feeling that I'm going to want to leave it like that. I'm not going to distribute. You know why? Because that x and that x cancel out. And I'm left with the limit as h approaches 0 of h over h times stuff. Now, I've heard of h and r puffin stuff, but h times stuff, that's different. You cross out. So if I plug in 0 for h, what I get on the bottom is I get 1 over, that goes away because I'm plugging in 0 for h. So I get root x plus 0, which is root x, plus root x, which is 1 over 2 root x. I have to plug in 4 because it says so. The square root of 4 is 2. So the slope of the tangent line for this equation right there is 1 over 4. And again, if you want to look at that graphically, looks like that. So when I plug in 4, so 1, 2, 3, 4, when I plug in 4, the slope of the tangent line is going to be a nice, very shallow line with a slope of 1/4. Velocity, as opposed to speed, can have negative values because not only does velocity give us speed, it also gives us direction. So depending on what the word problem looks like, if I have something like negative 10 meters per hour, that could mean I'm either going backwards or I'm going downwards. It all depends on the wording of the word problem that you have. When we find the slope of the tangent line and we plug in a number for x, what that does is that gives us instantaneous velocity. How fast is that object moving at a given time? Okay. So in the next problem, what we're going to do is we're going to be given a formula that represents positioning, and we're going to be able to find the velocity by taking the slope of the tangent line and plugging in a point. All right, so taking what we learned about the slope of a tangent line, let's apply that to this guy right here. A ball is tossed in the air and its position is given by the equation h equals f of x equals blah, 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 blah. H, of course, representing height. In meters, x is seconds. Find the velocity of the ball after 2 seconds. So we have to take the slope of the tangent line. So m tan is the same thing as the limit as h approaches 0 of f of x plus h minus f of x over h. So what I really need to do is I need to find out what f of x is and what f of x plus h is. And this is going to be the fun part, the messy part. F of x plus h is negative 2 times x plus h squared plus 5 times x plus h plus 2. Remember, when you're finding f of x plus h, you are substituting x plus h in for every x. X plus h in parentheses squared is x squared plus 2xh plus h squared. I can distribute that guy. And plus 2 is just kind of hanging out. I can distribute that guy and get negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h plus 2. And I don't see any combining like terms going on here. That's unfortunate. That's unfortunate. Made it a little bit easier, but we're not there yet. I mean, I'm sure that will, I'm not sure, I know that will happen. F of x is negative 2x squared plus 5x plus 2. So let's use that formula right there. We have the limit as h approaches 0 of f of x plus h, which is negative 2x squared plus 5. Oh, I'm looking at the wrong thing. Minus 4xh minus 2h squared plus 5x plus 5h plus 2 minus negative 2x squared plus 5x plus 2. It's going to be over h. So let's drop the parentheses and distribute that negative, and that's going to give us negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h plus 2 plus 2x squared minus 5x minus 2 over h. As we know at this point, expect things to disappear. Like you guys, like you guys, like you guys. And what I'm left with is negative 4xh minus 2h squared plus 5h over h. Oh, look, there's an h in common with all of that. Who would have thought? That's going to end up being the limit as h approaches 0 of h. Bringing h out of negative 4xh and you get negative 4x. Bringing h out of negative 2h squared and you get negative 2h. Bringing h out of 5 and you get 5 over h, cross you out. All the h's become zeros, and in this case, you're the only one that goes away. So this is going to end up giving us negative 4x plus 5. I care about the second, right? 2 seconds. So I'm going to plug in 2 for x. That's going to give me negative 8 plus 5, which is negative 3. And we're talking about meters per second. That's my velocity. So we have a graph. Looks like this. Here's 2. It's going to go up. It's going to go down. And we care about what's going on at the second, which is probably somewhere around here, based off of what we know. And we get negative 3. Nifty. Nifty, 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 nifty. That wasn't so bad. So the slope of the tangent line at a given point gives us that slope, that rate of change. If I wanted to find the average rate of change over an interval, I would just simply use the slope formula, which is right there. The book would do this, where instead of using the y's, they'd use the f of x's, but it's the same exact thing. The average rate of change is the slopes formula. It's just more often than not, I would give you what f of x equals, and I would tell you, like, I would say f of x equals function. And I'd have to find the y value. So, back when you were in Algebra 2, maybe I'd give you 2 points like this, and I'd say, hey, find the slope of the line connecting these two guys right here. And so you just use slope formula right there. But now what I'm going to be doing is I'm going to be like, all right, well, I'll give you this guy and I'll give you this guy, and I'll tell you that y equals 3x squared minus 1. Find your own y's and do the same thing. That's what we're going to end up doing next. So while I'm at it, before we do this problem down here, and I'll do this problem on a scrap sheet of paper because I definitely don't have enough room. The instantaneous rate of change when x equals a number is similar. You see, what we do though is instead of just going with the slope, we're adding limit to it. So if I ask you the same thing, if I'm like, all right, well, here's an equation. I'm just literally writing something down. I need the instantaneous rate of change when x is 3. That's my f of x right there. I'm going to find out what that is and plug in 3. And then I'm going to use x, and then I'm going to subtract 3 and take the limit as x goes to 3. Okay. And so let me switch over to paper format, and we'll do this problem and one more problem after it. I think that's it. We're done after that. So the average rate of change. Okay, the average rate of change is basically the slope formula. So like I said, I have an x value and I have a y value. What I need to do is if I plug in 1, actually these are both x values. I'm sorry. I knew that wasn't right. If I were to plug in x to the, or 1 for x here, I would get 2 times 1 squared minus 1. 1 squared is 1 times 2 is 2 minus 1 is 1. So this guy right here would be my y sub 1. My y sub 2 would be that guy if I plugged in 3. So 3 squared is 9. 2 times 9 is 18. And 18 minus 1 is 17. So the average rate of change is just the slope formula. M equals x y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 17 minus y sub 1 is 1 over x sub 2, which is 3, minus x sub 1, which is 1. 16 over 2 is 8. And I don't have any units here, so I'm just going to leave it as 8. This, my friends, is instantaneous rate of change. Instantaneous rate of change. So I care about when x is 4. So f of x, and I'm just going to write out every part. I'm going to write out what f of x is. I'm going to write out what f of 4 is. Remember, if x is 4, that this would be my x sub 0. All right, so f of x is 2x cubed minus 1. F of x sub 0, which is f of 4, is going to be, hold on, let me make sure you can see what I'm doing. Yeah, you guys are good. F of 4 is 2 times 4 squared minus 1. 4 squared is 16. 2 times that is 32. 32 minus 1 is 31. X is x. And x sub 0 is 4. Time to plug it all in. The limit as x approaches 4 of f of x, which is 2x squared minus 1, minus f of x sub 0, which is 31, over x, minus x sub 0, which is 4. Two x squared minus 1 minus 31 is 2x squared minus 32 over x minus 4. Can I plug in 4? Nope. So let's try this. Let's try pulling out a 2. Can I plug in a 4? No. Can I factor that? Yes. That would be a difference of squares, kids. The limit as x approaches 4 to, remember, difference of squares. A square minus a square means you get the square root of the first part plus the square root of the second part times the square root of the first part minus the square root of the second part, which is good news. Because a factor upstairs and a factor downstairs are the same thing. So now I can plug in negative 4. Or I'm sorry, I can plug in regular 4. And when I plug in regular 4, I get 2 times 4 plus 4, which is 2 times 8, which is 16. No units. Shall we do it again? Let's do it again. But might be a little less pleasant. Average rate of change over the interval 2, 8. So that's an x sub 1. That's an x sub 2. My y sub 1 would be if I plugged in 2 into that equation over there. So 2 over 2 is 1. My y sub 2 would be if I plugged in 8 into that equation over there, which is 2 over 8, which is a quarter. Gross. I'm going to use tried and true slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is a quarter. Minus y sub 1, which is 1. Over x sub 2, which is 8. Minus x sub 1, which is 2. This gives me negative 3/4 over 6. And I'll put over 1. Whenever you have a fraction divided by a fraction, we've seen this recently, you multiply the top and the bottom by the reciprocal of the denominator. That crosses out. This becomes negative 3 over 24, which simplifies out to negative 1/8. Instantaneous rate of change, as you may or may not recall, was the limit as x approaches whatever number we're talking about of f of x minus f of whatever number we're talking about over x minus whatever number we're talking about. And in this case, we care about 4. So I need f of x, which is just 2 over x. I need f of 4, which is 2 over 4, which is a half. Ugh, barf. Just making sure again, I have to click on this thing over here. Oh, wrong button. There we are. Yeah, I was afraid you would be able to see what I was doing. All right, so f of x was 2 over x. Boom, boom. F of 4 was 2 over 4, which is a half. X is x. And x sub 0 is the 4 that we used. So this guy becomes the limit as x approaches 4 of f of x, which is 2 over x, minus f of x sub 0, which is f of 4, which is a half, over x, which is x, minus 4, which is 4. Before I go much further, I should probably multiply this guy by 2 over 2 and this guy by x over x so I can eventually combine those things. So let me write that over here. I'm afraid I don't have enough room on the right and make it look decent. 4 over 2x minus x over 2x all over x minus 4 over 1. Now I'm putting that over 1 again because I kind of have an idea as to what's going to happen. Something similar to over here is going to happen. All right. 4 minus x, the limit as x approaches 4 of 4 over x over 2, x over x minus 4 over 1. If you have a fraction divided by a fraction, multiply the top and the bottom by the reciprocal of the denominator. So I have 1 over x minus 4, 1 over x minus 4. So that'll cross out. It's going to end up being the limit as x approaches 4. Now, before you get all excited and giddy, these two are not the same. They're not. But what this is if I were to take x minus 4 and multiply it to negative 1, I get 4 minus x. So what I'm allowed to do is I'll keep this the way it is. I'll keep that the way it is. I'll keep this the way it is. I'll bring out a 1 for this bottom one and switch that to 4 minus x. I'm allowed to do that. Why do I want to do that? Well, you'll see in just 1 second. Bring it down here. The limit as x approaches 4 of 1 times 4 minus x is 4 minus x. Negative, I'll bring out front. 2x, I'll leave there. 4 minus x. Now, I can't plug in 4, but you know what I can do now? That. And that leaves me with 1 over negative 2x, the limit as x approaches 4. I can now plug in 4 and get 1 over negative 2 times 4, which is 1 over 8 again. Negative 1 over 8. All right. And I think that does it. That does it for the chapter. I wish, right, guys? Does it for the section. Long section. Next one, it gets easier, I promise. Bye.